All right, guys. So, good morning. We'll be basically continue on the last objective. So, we have finished the first like 6 or 7 topics, and then we'll be having the remaining 2 topics. I'm sorry. I would say 12 topics, something like that, before the exams. All right. So what are we up to right now? So let me double check that. Um, I'll send an email quickly regarding to the final exam. So just give me a few more minutes. It should be on Monday, December 22nd. So let me, let me just verify that um the final the final knowledge check must be uh completed within like on Saturday and Sunday. So you're gonna get 2 days to get it done. It's 5% your grades. Make sure you're gonna get that. We also have objective 4 being closed on Wednesday, December 10th. We also have a data day for on December 9th. You have to be on Zoom the for the final exams. Yeah. The final exam is have to be on Zoom. It's literally on Alex. I'm sorry. I'm sorry. I have to mute. For the knowledge check, you don't have to. So let me just verify like some kind of information towards the final exams. So the final knowledge check is 5% of your grade, 5% of the final grade, right? Of the grade. It's not like one exam. So one exam only 10%. So this is half of your exam's grade. It can be, I'm sorry, it can be on Saturday and Sunday, right? Between December 20 or December 21st. Okay. One of these 2 days, I will let you know. And the last day that you have to complete all of your objective. So let's say you was late to the objective. They want to complete them until I want to complete them, even if it's I was I turn out I turned the homework late. It's December 19th. So last day to complete all the objective. And also the exam 4. And so we have some kind of informations that we need to put it down. So we have data day 4. It should be on December 9th. So this data day is kind of easy. is on the linear regression. It should be a very brief introduction. The final knowledge check is based on the answers. The accuracy is not completions because the grade based analysis. So you have to complete the knowledge check based on the answers that you submitted is not the completion of the knowledge check. Well, I mean, some of you I just checked them when you complete the knowledge check on each modules, like post module knowledge check. Some of you just basically fill up like some random numbers. It doesn't matter. But like I said, but this is degree based knowledge check. Oh, yeah, no worries. The word possible time. So yeah, 120. Well, if you multiplied it by so you went from here to here, right? Now we have everything else is good. Yeah. Well, actually, it's two to the 10 minus 3. All right. And then exam 4, I believe it's on December 12th. So we literally don't have time to review. So there's no review for this exam 4 because, we just don't have time for that. There's no exam review for exam 4. So make sure that so the last objective always be like very long and it's very complicated. Um, which is why you have to be extremely like careful. You have to study a lot for the exam 4. So this exam is mandatory. So making sure we have to take exam 4. Okay. All students must take exam 4. Objective 8, just one objective. Yeah. So exam 4 include question from objective 8, and that's it. If you can do all the questions from objective 8 without any issue, without any problem, you should be good. And the final exams, I will let you know. I will send out an email. Remember, there's so many topics, there's so many different things that I need to go to, which is why it might take a little bit long to get it done. All right. So we're gonna continue on the topics, and I would likely asking us to go to the formula sheet, something like that, to find the equal variances or unequal variances. So it is one of the things that we need to understand. So we're gonna write up the question in this case. The question says the mean time was 197 with a standard deviation 7 to 8. And each group has like 15 patients. So we have like M1 equal to 15 and N2 equals to 15 as well. We also have the sample standard deviations. Oh, N2 was 8. I'm so sorry. Patient. And then we also have the X1 bar equal to 193 dates. And we also have the sample standard deviation. So that's 7 dates. And then we also have X2 bar in this case. It was 187 dates. Okay, so that's gonna give us the sample standard deviation for the second group was 6 dates. So we know the fact that they have the equal variances. So it's very rare that we need to assume that two treatment have the equal variances. That means that they have the same standard deviation, the same variances. So the form that we're gonna take based on what we have over here. So we're gonna estimate the mean. So this is what we have for the formula sheet. I also have posted on objective 8 for the analysis. It's something that I put it right there. So this one is kind of like really complicated process because it requires us to test the means by comparing like two different sample from two different populations. So I sort of skipping that part, but we can simply compare that. So for the hypothesis that we're going to take, we're going to compare the mean one, mean two. The keyword for that was um is greater than. So we can look at that. It's a we don't need to care much about these we need to identify the keyword for that, which is greater than. So that's the thing I need to um do this. So that when I set up the hypothesis, it's have to be um the top was equal and then the bottom was greater than. So the mean was we have to write mean one was greater than mean two. So we're gonna do the same thing for the no hypothesis, which we have no information with. Objective 4 would be on the exams. Oh. All right. So we have to use the t-test because we do not know the population standard deviation. So we only have a sample standard deviations. This is not a pair t-test. Apparently, this is the independent t-test to make sure that the population ones is independent of population two. All right. So now we can. So now we can just simply um write up the hypothesis. Okay, and then after that, we're going to compute the t-statistics is based on the degree of freedom was n minus 1 degree of freedom was n1 plus n2 minus 2. So we just combine 2 degree of freedom. So we're going to have this one is 15 plus 8 minus 2. So 15 plus 8 minus 2, we get 21 degree of freedom. And then we can also compute the t-test based on x1 bar, x2 bar. And divided by the sample standard deviation. So we can compute the SP first. So SP square is simply like a pool variance between these two. Two pop two samples. Okay, so since there we have to assume it to be equal, so we have to find a pool variance. So we just have to divide it by the square root of this. All right, so we're gonna compute it on a calculator. Like I said, that we can't do it by hand. So we have to hit divide first. You can take mean one was 193 minus 187 divided by the square root. So that's the big calculation. That'll be m1 minus 1 times s1 squared. So m1 was we have a 14, 15 minus 1, 14 times. So we have to hit another divide. And then you get 14 times the standard deviation squared times the variance. So it would be 7 squared. And then plus we do the same thing. N2 was 8 minus 1 was 7 times S1 squared. So S2 squared will be 6 squared is 36. And divided by the sum of which is the degree of freedom of two population, two samples. So we just compute it as 21. So we're gonna get this one is 8. Let me just copy that formulas and making sure that we don't make any mistakes on it. So that says 89.77. I'm sorry, 0.8977. All right. So this 0.8977, this 0.898. And then we need to find a critical value, that's TC, based on 22 degree of freedom. I'm sorry, 21 degree of freedom um and 5% is one tail as well. So you want to find the t-score. No, I'm sorry, t-score of 0.05 and then 21 degree of freedom. So we're gonna get this one equal to it's 1.72. Oh, I can just copy that. Right. So the TC was 1.72, one, something like that. And then would you conclude, we conclude no, we cannot conclude anything because we have a T less than TC. Less than, this one in absolute value, just take the magnitude, less than TC. So we're gonna reject H1. Do not claim anything. So we don't have enough information to claim anything, even if the mean was 193. This is for the samples, it's greater than 187, but they have like a relatively big standard deviation, so we cannot say anything. Hold on, partially correct. I think there was something wrong with the hypothesis. So let me. It should be it should be due like less than equal to. There's something. It's 2.051. Hold on, let me double check that. There might be something wrong with this. Oh, if we forgot to um let me double check that. Um I have to take the square root of SP, the square root SP over yeah, so let me double check why this one is not correct. It's 2.01 or something like that. Maybe I just miscalculated something. Um Okay, so let me double check that. S1's minus 1 times S1 square. S1's that we have was 7 square. That looks perfect. Plus 7. So it's 8 minus 1 is 7 times 6 square divided by 21. So that's N1 plus N2 minus 2. That looks good. And it doesn't tell how much difference between these two. Yeah, so let me double check. Um, yeah, it's so I might make some mistakes over here, like in one you have to take the square root of that, then So we're gonna take and 2 minus 1 with a minus 1s was Mm. So let me compute SP separately. I think there's a little is here. So the SP was M1 minus ones times, so the M1 was 15 minus 1 times the standard deviations, I mean the variance, S1 square, it'd be 7 squares, 49 plus N2 minus 1, so that would be A minus 1 times um S2 was S2 was 6 square is 36, and then um divided by 15, I'm sorry, 15 plus 8 minus 2, like 21, and take the square root of this, 6.6833. Yeah, it should be that. And then 6.6833, and then divided by 193 minus 187 over 6.6833. So that's they might use different things, but it's just, let me double check that real quick. It can't be like that. It should be something that we have so far. Um Maybe let me try different things. 193 minus 187 divided by the square root of the standard deviations, 1 square over um over over n1 was 15 plus 36 over n2 was 8. Let me double check that. It's 2.0. Yeah, there must be something wrong with that, with the SP or something, because yeah, it can't be that small, and then there must be something. Let me double check my formula sheet real quick. There are actually two things. Um, yeah, it's basically the same thing that we have over there, and then the SP square. Oh, I think we have to divide it by radical n. Oh yeah, so you have to multiply by radical n. So yeah, that's probably the reason why that we have to do so. Yeah, after we get the SP, we have to divide it by radical n again. So divided by radical n. So this is um okay. So now I just simply multiply by 0.8977 times um radical 21. No, it's kind of be like that. It's kind of be like 4.2.015. That's kind of weird. Oh yeah, they have a UNIS. Oh yeah, so that'd be SP square. So need to compute this separately. So SP, after we do the SP, you have to plug that into the form. So this is not a symbol we have for the calculation, right? Like that. So, all right, guys. So this is more complicated part that we have to get it done. First, we have to compute the SP separately. Yeah, this question was sort of um harder. So we're gonna take the M1 was 15 minus 1 times S1 square was 7 square plus N2 was 8 minus 1 times N2 square was 36 divided by, yeah, we can't combine them into a single calculation. N1 plus N2 minus 2 is 21. All right, so you must compute this separately. So you're gonna get like 44.667. When we have like two samples, it's really hard to do every single calculation at once, single format. And then we're gonna do so for that part we have to do different things. So we're gonna take the SP times um square root of SP is 1 over N1 plus 1 over N2. Honestly, this question's like if we separate them into like two different calculations and then we have to assume that the variances are equal, it should be done like within two calculations. When something done within two calculations might be a little bit hard because we cannot separate them. If this one is going to be kind of complicated when we do it on a calculator. I do not know, but it might be on the objective four, but it's not going to be on the final exams. So now we can just compute that. We can just compute that on a calculator. Let's say this divide. We're gonna take 193 minus 187 over the square root of SP squared is 44.667 times 1 over N1, which is 15 plus 1 over N2, which is 1 over 8. It wouldn't be too bad. But we have to do like two separate calculations. Yeah, if you're not willing to do like two calculations, it might be a little bit complicated. You have to combine numerators and like a bunch of calculation on denominator. And now you can get to the final answers for that. So we're gonna get 2.05. Yeah, this is what we have. It's not gonna be on a final exam for sure, 100%. Yeah, it's a slightly, and then since we have the T was greater than TC, you're gonna accept H1. You're gonna say yes to the claim. All right. Yeah, so we have to compute the pool variance first, and then we're gonna plug that in to compute the t-test, the t-score. and then to the final answer. So that's gonna take a little while. I know it's not gonna be easy at all because you know, because of the amount of work we have to spend on it. And we can try another one, but that one's even more complicated because we have to send them in the calculator. And we're not gonna spend the whole class on that. That's fine. It's gonna be all right, first you're gonna compute. So each of them has like 15. Okay, so let's do that again. It's not really complicated. So we're gonna have x1 bar equal to, gonna compute it on a calculator. All right. So first we're gonna send the data set to the calculator. Like I said, we should not do it by hand. You send the first data set, and then we compute the mean. We got 71.73, and then we send the data set to another calculator, and then we compute the standard deviation. We're gonna get 3.955. And we do the same thing for the second data set. You're gonna send that to the calculator. I have to erase that first. So we got 74.067. And then we do the same thing. We're gonna send the data to the calculator. We compute the standard deviation. We got 2.939. All right. So we can set up the hypothesis. This is the pair t-test. I'm sorry, this is the two-tail because it says we test on the difference. So we're gonna do different on top was equal, and this is mean one is not. It's different from mean two. And the no hypothesis just do the same thing, but instead of the difference, just set the equal sign. Ah, oh my goodness, do that again. Okay, so this is a t-test. Degree of freedom is n1 plus n2 minus 2. That's 15 plus 15 minus 2 is 28. And then after that, we're going to set up the hypothesis. We're going to compute the SP square. Have to be done on a calculator. So you're gonna take n1's minus 1 is 15 minus 1 times the standard deviations, um which is 3.955 square plus n2 was 15 minus 1, which is 14 times the standard deviation that we found 2.939 square over n1 plus n2 minus 2 is 28. So we're gonna get like 12.13, 12.14. All right, guys. So, and then after that, we're gonna set up the hypothesis. After we state the hypothesis, we're going to so there's 20-degree of freedom. So we're gonna compute the t-statistics. All right. So the t-statistic is can be computed by on a calculator again. Yeah, we have to do like two separate calculations. So we cannot do any shorter than that, which is why it's kind of hard. So we're gonna take the divide, take the mean one was we found was 71.73 minus the mean two that we found was 74.067 over the square root of SP square was 12.1398 times, well, 1 over n1 is 1 over 15 plus 1 over 15. So that essentially going to give us the answer, which is negative 1.837. All right. So after that, we're going to look at the t-score and so on and so forth. Negative 1.837. And this is 212, so we're gonna go for the t of 5%. So we're gonna take 0.025, which is divided by 2, and 28-degree of freedom. So we're gonna get negative 2.0848 and positive 2.48. Okay. So the answer is no. All right, correct. Everything is perfect. There's nothing really hiding um in this case, so we got this done. You think you can do these questions on the exams? Okay, so no response. Let me just continue on it. So 0.025 and the grid field is 28. Just divided by 2 because we have a alpha is 5%, this two toe. All right, and then let's move up to the next question. No, some topic was very ugly. That's very concerning. But if you have a calculator, so we can deal with that. Okay. In this question, the form is clear. Yeah, it's yeah, we have to divide the forms like that and then just compute it. There will be like two calculation. The two pick calculation you have to do. One was for SP, the pool variance between two samples. And then after that, we have to compute the t-score. Um, and then we use a calculator to compute the critical values. So that might be a little bit hard. All right, so now we're gonna compute the expected value. So we can also use the chi-square to test on the multi-proportions on or to test on the contingency tables, whether they're independent or dependent. Which is called a Goodenough fits. Okay, so it's a very special thing because the chi-square work with the probability concept based on the one single proportion, like multiple single proportions, because the chi-square is the sum of the z square, which is why we cannot test each of them separately, but we have to test like um combine proportions. So the independent just basically P of A and B equal to P of A times P of B if two of them are independent. So in other words, we can always compute this number by taking like 36 times 48 over 150. So this box can be answered by taking um 48 times 36 divided by 150. Okay. So we take 48 times 36 divided by 150. So we get 11.52. And then this box can also be computed by 61 times 34 divided by 150. So that'd be 13.82. All right. And and the same thing, we can do like 53 times 68 over 150. You should get to the final answers. And that one was we take 53 times 60. This question might be on the exam. It's just so simple. And then 24.03. Yeah, so it's literally just taking the total number of rows, so we can find the assume the independency. So we can take so we can take um, the expected you can take the en expected en is equal to the corresponding row times the columns over the total. Yeah, you might have this question on the exam, but of course not going to be in the final. All right, it's nothing really special about these questions, and let's move up to the next one. The goodness of fit, like I said, we're gonna test the multi-proportion at the same time. So at least one of them was different from the rest of the proportions, because chi-square basically independent of every single proportion that we have. So we basically gonna do the same thing, um but we're gonna have like different proportions. Very like symmetric. Okay, so now I just need to do this. All right, so you're gonna find the expected frequencies based on the proportions by the expected proportions. So it was 50% between 0 and 2. So P1 was 15%. So therefore we have the expected frequency was E1 is equal to 115 times the total. The total that we had, which is add up the observed frequency, was 42 plus, does it say anything? It's 200, right? It's 200, random sample 200. So we got this one is 30. The same thing for that. We're going to take the E2. The proportion we're given by 10% between the ages 13 to 18. So we take 10% times 200. So we got 20. So this is what we expect to see with the assumed proportions, and then we trying to disprove it. So in statistics, we can disprove, but we can't prove anything based on a sample. So the proportion that it says was like um 15 and then 20 compared to the observed frequency was 42 and 29. And then you want to see if that's meaningful, if the difference become meaningful or not meaningful. So we need to subtract them and square and divide it by the expected frequencies. So let me just let you know the expected frequency, which is FE or E, whatever you want to call. So that'll be the total number of samples times the proportions. That'll be n times p. Okay. Then we can compute this one by subtracting 42 minus all right, so we're gonna take 42 minus 30 square divided by 30.
Oh, was it the, yeah, was it the polynomial, like the leading coefficient?
Oh, yes,
Yeah.
I hated that and I couldn't remember it.
No, it's so great, it's so, it makes it so,
Great.
so it's,
No, when you simplify like that, it actually makes.
So we get 4.8. The same thing for that. We're gonna take 29 minus 30 square over we can do the subtract because it was given over 20. But the question gives us, oh, the question does not give us a total. Yeah, unfortunately, I have to do that. I think the question gives a total for that, so that would be so much easier. But now it doesn't give a total, just the corresponding for over 55 years old. So we're gonna take the divide and 29 minus 30 square over no, 29 minus 20. I'm so sorry. 29 minus 20 over 20, and you get 4.05.
that's when it's good. With the y-axis,
All right, so that's pretty much it. Any questions? Any concern? So you might see some of these questions. Oh my god, I have to test it again. Yeah, so the testing it's kind of so this is a chi-square test. Yeah, so we have to do the test as well. I'm not sure if you're gonna see this question. There are not a lot of work we have to do. So the degree of freedom is based on the number of proportion that we're testing altogether. So we have 1, 2, 3, 4, 5. So there 5 minus 1 is 4. And then the chi-square test, the test that the chi-square statistics is based on the sum. So the chi-square, so we have a square on top. The chi-square always positive, and its number 4 represent the degree of freedom. So we're gonna add up like 4.8 plus 4.05 plus 0.0117 plus 0.72 plus 6.4.
you're saying that if, instead of going down like this, it's like this. But how would it look if you just put it down instead? Imagine, like look at x squared. Oh, x,
I got 15.987.
so you're saying that, why is it that minus?
And then you can find the critical values based on that, based on the chi-square. The chi-square, which is how much percent are we testing right now? Um, its critical value is, it doesn't say anything. It should be 5%. It must give us critical, the significant values.
No, Now, stop visualizing a cube and visualize Mars.
Yeah, it should be 5%. Degree of freedom is 4. So that'd be 9.48.
The cool thing about the cubic problem.
All right, so we're gonna say yes. Oh my, we still have more. Oh, degree of freedom is 4. Yeah.
Is equal.
All right, everything is perfect. Any questions? Any concern? Yeah, that's a lot of that's a lot of work for this questions because first we need to figure out the t statistics. I'm sorry, the chi-square statistics, and then we need to look for the degree of freedom. It doesn't say 5%. If the question that doesn't say 5%, just use 5%. Oh, yeah, it said 5% right here. I'm so sorry. It said 5%. Yep.
It's not. It's actually a P.
Yeah, the critical value can be found on the chi-square of 5%. And then for degree of freedom, because we're testing on 5 proportions. It's okay. I got you. Okay. I feel like that's pretty much it. Any question, any concern? Like I said, I don't think we are able to finish all the topics because we test on independence, we test on goodness of fit, we test on ANOVA, regressions, coefficients, and then we also have to do the side test, recursion side test. All of this I uploaded on Objective 8. I will try to summarize as much as I can, but there's so many different topics, so making sure that um you're able to do it. Yeah, that one is easier. Let's do that. One question. This question will be on the exam 100%. So do not try to focus like the parity test might be on the test, but like I said, like independent t-test and you know, you may have to perform like more than one calculations. If you have to do more than one calculation, this it might not be on a test. Um, so the average change based on um additional mile from the house to the nearest school, the sale price. So this one is very straightforward. Just have to look at the coefficient. Is will be changed for the dependent variables. In this case, will be the sale price. And if we basically at 1 mile from the house, like the mile was based on X3, right? So the question says mile, additional miles. So it's based on X3. Okay, so the X3, like whenever it's far away from the school, the less expensive the house will be by the 4 coefficient. So so for 1 miles away from their uh from the school, then the sale price will be dropped by 4 times 1 miles, correct? In the $1,000 range. So for every 1 mile, it's gonna drop $4,000. So we're gonna just put down 4,000. And then it should be a decrease because it has a -4. So it's coefficients. -4. So that would be decrease. Yeah. So first, whenever you see the question like that, make sure that you look at coefficients of the variable that it talks. And then afterward, we need to identify whether it's negative or positive correlation with that variable. So for the regression model, just simply just look at that. So you're gonna get 4,000, and it should have to be decrease. Okay. Yeah, every question gonna be the same. So let's say um that like 100 square feet increase. So the square feet is in terms of x1. So x1, so whenever it's go up by 100 square feet, so this one gonna be go up by $6,400, 650, 6,400, whatever his increase. Yeah, something like that. It's very straightforward. Just have to make sure we identify the correct variables and just take the coefficients to answer the question. All right, I believe that's pretty much it. Any question, any concern? Okay, so now um I have to take attendance, I'll let you go.
It's so broken. Yeah. It's the ending of the audience and fixed before New Year. Right.
Then.
Yeah.
Yeah, make it a little smaller. Just make it have enough space for that. All right, Jasminer is here. Malika, Annie. Yeah, just type here and then, just leave Zooms. If you have an emergency. Rachel, Selena, no, Hashan, Samina, Sarah, no, Alexis, Z, Maureen, no, Jocelyn, Falari, Nadia, gotcha, Nicole, Tina, Ariana. Yeah, just type yes, Nicole, Karen, meet her, Amama, meet her is here, Lisa, Shira, Catherine. Its objective A was due on Wednesday, December 10th. I know it's been a lot of work. Yeah, I don't think we have much time to finish it, honestly. This is the best we can do. I would try to finish it by Friday. Let's see how many topic we can go to. And then Chloe, Elkin, yes, Sarah is here, right? Yeli, Damaris, William, yeah, just Lenny, gotcha. All right, let me double check with the Sarahs here. And yeah, that's pretty much it. All right, I will see you on Friday. Take care.
Professor, is there maybe a mistake because I haven't missed a day and I see that I have a box missing. Like
Let me double check that.
I know in one of the Zooms,
Yeah.
one of my classmates had to write you because I was having connections issues, but I was
Yeah.
still present.
Okay. Gotcha. All right. So I'll see you on Friday. Take care.
Okay, thank you so much. Have a good day.
You too. Bye bye.